Welcome back to our Be Kind for Lyme interview campaign. So excited to have another special guest, Dr. Thomas Grier. He has so much information that we are probably going to do more than one video. And this is the month of June. May is Lyme Disease Awareness Month, but for us, Lyme Awareness never ends. And we're going to continue these interviews. So we welcome Dr. Thomas Grier, and he's going to give us a little bit of a backstory of his wealth of knowledge in his studies and his background, and then we'll go into some of his research.
All right, thank you, Holly. Well, keep it brief. I did my schooling at the University of Minnesota Medical School in Duluth, Minnesota. And after that, I decided to go into research. And so I transferred out to the West Coast, where I worked actually on a grant from NASA. We were studying osteoporosis and worked at several places, the McCord Air Force Base, and worked through the university, both University of Washington and Puget Sound. And after that, I went into the pharmaceutical industry for a while. And that's about the time I started getting sick. And it just kept progressing and progressing to the point where I actually became disabled. I was actually bedbound. And at that time, I was on a waiting list for a nursing home. I was diagnosed with multiple sclerosis, and it turned out to be a misdiagnosis. I had Lyme encephalitis, and it was just an accident that I got diagnosed correctly. I had collapsed in the street. I was taken to a hospital that my doctors don't use. And the doctor that came on, the neurologist, had just been to a Lyme disease conference in Arlington, Virginia. And she said, I think you have Lyme disease, and we're going to start your treatment today, but we're also going to pursue the multiple sclerosis connection. And as it turned out, she was right. It took, at that time, 6 weeks to get our results back. At that time, there was not a lot of places to send blood work. And I was positive. I got treated, and that's when all hell broke loose. I got so sick. The pressure in my head just exploded, visual hallucinations. I couldn't sit in an upright position without passing out. The pain in the muscles and joints was terrific. And so as the therapy started, I started to attend conferences, and that's when I hooked up with Dr. MacDonald, and he and I became good friends, and we kept in communication for many years. So from 1990 to 1997, pretty much I was going to conferences every year and talking to different doctors and so on, and writing my own little pieces. And we decided that we would team up together and start doing some projects. And so that's when I teamed up with Dr. MacDonald. So does that help you?
Wow. What makes this interview super exciting for our viewers is you are going to do a screen share and show us some slides. And you do autopsy pathology, and your research is unlike any other Lyme research. So we're going to let you take the reins and show us the visuals and give us some layman definitions of what you're showing us.
All right. You're seeing this okay?
Yes, we see it.
All right. One of the things that I noticed right away in Lyme disease research was almost nothing was being done in research that involved human pathology. And this is ridiculous. We have a disease that's misunderstood, and all the monies were going to deer studies, tick studies. And so I had talked to Dr. MacDonald, who is a pathologist, and he said, you know, it's not impossible to do brain autopsy studies on our own, one at a time. And so you just have to register patients, and they have to be absolutely dedicated to the idea that when they die, their family will harvest the tissues and everything will be done correctly so that we can do the research. Mm-hmm. And our first case here was in 1997. I'm clicking on it, but I'm not getting it up. There we go.
Okay.
If you look here, this is an Alzheimer's patient from Ashland, Wisconsin, who, if you look, we're seeing a spirochete that's half in and half out of a brain neuron. And this is the first time in anywhere that Lyme disease had been documented to be intracellular in a brain cell in a human. Everything else had been test tube studies. We were the first to show this. And this is very important because way back in 1997, this pretty much meant that Lyme disease could be considered either difficult to cure or even incurable, and also almost impossible to detect with the current state of serology tests or blood tests. So this was very, very important, our very first brain autopsy, and we were surprised at what we found. Almost every cross-section of the cerebral cortex in this patient was positive. Now, the CDC, going back to 2006, knew that the bacteria could go intracellular into brain cells. And this is work by Dr. Jill Livengood and Dr. Robert Gilmore at the CDC. And they used a very expensive microscope, a laser confocal microscope, that can give you computerized 3D imagery of a live cell. And what you're looking at here is a brain neuron in culture, human brain neuron, and then we see the spirochete. This is Borrelia burgdorferi. Whoops, I just changed my slide. Borrelia burgdorferi that's inside that neuron. And what they found was in their study that Borrelia burgdorferi had a tropism for brain cells, both the glial cell and the neuron, and it would be attracted to these cells in matters of minutes. It would penetrate the cells in matter of minutes, and they would live there. The length of the study in the Petri dish was 7 days, and they would live inside the cell alive for the entire 7 days. So this is a big discovery, and yet they don't really share that, and it's getting harder and harder to find this study posted. So I urge you, if you haven't read it or looked at it, they probably have about 40 really excellent pictures.
And we're going back 10 years that they knew and they know.
Yeah, yes, absolutely. Now our more recent work, and this is very recent, we took samples from a multiple sclerosis brain bank, and the 10 consecutive samples that we got, we put a drop on a slide, we stained it with a very simple stain, ethidium blue, and then we looked at a very low magnification, sometimes as low as 4 power or 10 power. And what we found in all 10 samples were these parasites. These are nematodes. We're not quite sure what species there are. There's probably more than one species. We're pretty sure we have C. elegans, but various species of nematodes. And these are about 100 times bigger than the Borrelia bacteria. Now, there is evidence to show that Borrelia can infect patients' brains and give an MS-like condition. And that's a whole nother topic and study. But this is very important because these patients are probably very treatable. All we're looking at here is a treatment with an antiparasitic drug, but it's important to get it early and a drug that penetrates the brain. So.
And what I know you and I had, before we started the interview, what are the ones that, the drugs that penetrate, what are the ones that are for sure guaranteed?
Well, I think the research there is very scant, so we don't have a good understanding of which ones penetrate the brain. We were talking earlier, you and I, about Mepron, if Mepron works, ivermectin. Most of the medical community seems to lean towards thiobendazole. And thiobendazole is no longer approved for human use, but you can still get it through compounding pharmacies. The analog to thiobendazole that is available is albendazole and fenbendazole. And these are readily available also at pet stores and feed stores, like for horses. So they're out there. But the doctors have to get used to diagnosing this and prescribing this. We don't have any clinical records now of treating patients and seeing how they do. So that's the next step. We have to get patients treated and see what the experiences are.
What are the types of autopsies? With which diseases have you done under research? Is it ALS, MS, Parkinson's, like which ones?
Well, we take brain autopsies and we don't know what we're going to get until we look. And first of all, I'll tell you a little bit about the harvesting procedures. When a patient or a family of a patient is insistent that they want to do this step, we register them for a brain autopsy and we send them a 4-page registration form that gives them details. When the patient dies, we try to have the tissue harvest within 48 hours. That has to be done at a local hospital or a funeral home, and the pathologist has to follow certain steps. The easiest is to harvest the entire brain. It's soaked in something called brain formalin. And we firm the brain up, and then it's shipped to our facility about 3 weeks later. Our facility in Oklahoma then will take biopsies out of that brain, and it can be any different part. Like if we're looking at Alzheimer's, we might look at the hippocampal region. If we're looking at Parkinson's, we might look at the substantia nigra region. But any of those biopsies then will be thin sectioned, and then they're placed on slides, and then they have to be stained. And we're unique because we're the only ones that have DNA beacon probes that are absolutely 99.99% specific for each species of Borrelia that we're looking at. And we've got 3 probes right now that we readily use for Borrelia mayoni, Borrelia miyamotoi, Borrelia burgdorferi, and there's others that are in the works. So we'll see. It's not inexpensive to make these. It costs about $2,000 to make a batch, and they don't last very long. They have a short shelf life, and they don't do that many slides. So it's an ongoing process of when are you going to get your brain donations and when are you going to stain. So we try to group things together when we can, because that saves us time and cost.
Those who are signing off the papers after the patient dies, are they specifically Lyme patients that you are tending to get? Like how difficult is it to say that's what you want to do with your body if you were to die? I mean, if I were to die, I'm definitely going to give mine. I just wonder, like, maybe I'm asking too many questions at once, but is it difficult to do that?
It's not difficult if you're willing to meet with your family and have somebody in the family take this on so that when the person who's sick dies, that they know what to do. If you set it up a little bit beforehand, like if you talk to your family doctor and a local pathologist, then they know that they have to do this harvest and do it. So you try to set that up ahead of time. It's not really difficult. You just have to get cooperation. Now, the tissue harvest can cost anywhere between, sometimes a hospital will do it for free. Other times it could be as expensive as $2,000. We found the average price to be about $500 to harvest the tissue. And then that has to be shipped to us. From that point, we have taken care of all the costs of shipping, of the slide selection and staining, and that costs about $2,000 per brain autopsy. So no patient that I'm aware of has ever paid for their own brain autopsy, but we certainly encourage donations.
Right, and we will put that at the end of the interview on our rolling slide where we can send, if people want to donate money to that research, because that's super important. You said you did 10 on the slide before. There were 10
consecutive cases of multiple sclerosis, and we went specifically to a MS brain bank and got those samples. You were asking about what do we actually look for. Well, when we're doing certain aspects of a study, we get very interested, like Alan MacDonald was very interested in Alzheimer's brains. So for a period of time, he did nothing but Alzheimer's brains. And in addition to the brain autopsies that we did on patients, he ordered out over 100 brain samples from various brain banks that specialize in Alzheimer's. And then we would take those samples and run our tests on them. And what Alan found is pretty amazing. Then we got a very interesting case, which happened, you might know Robin Williams died tragically, and his mind was addled because he had a condition called Lewy body dementia. It's the second most common cause of dementia. And we got a case at almost the exact same time. And we looked at it, and we found also some amazing connections there. And so we were very interested for a while in Lewy body dementia. And then, of course, we've tried to look at Parkinson's disease and what you said before, chronic neuroborreliosis or Lyme disease of the brain. And we never know what we're going to find until we look. But this is, I want to show you this little slide here. This work was done at Stony Brook, and this is a culture of Borrelia burgdorferi on a live human umbilical vein. And the hallmark of this bacteria is it attaches to the vein wall or an artery, and it creates holes. And you can see these bacteria are going right through that hole. And that's exactly how they get into the brain.
Oh, that's like, so just to see this, I know this is going to be mind-blowing for our viewers. That's like mind-blowing.
Yeah, well, and I've shown, you know, here's the tragic thing is almost all the slides and science that we're showing you like this goes back to 1992, 1993. And I have given these slide presentations for 2 decades. And yet physicians look at this and they often, this is new to them. And I don't understand that. I mean, the information is out there. It's their job to know this. It's not really my job to know this.
Well, the doctors, I mean, I live in South Carolina. The doctors down here, I had gone to the emergency room for a non-Lyme related injury and had to talk about my Lyme based on how they were going to treat me. And I still have a doctor in that ER telling me that Lyme isn't here, so I surely got bit in another state in the north. I mean, that's like a month or so ago. They don't even explore looking at this stuff because they don't believe it's anywhere but in the Northeast. It's just mind-boggling. I have one doctor here that's willing to do ILADS training, which is great, but you know, as we know, that's going to take years for that to be perfected. But you know, that's one doctor in South Carolina, North Carolina, Georgia. We have none. So it is mind-blowing that you can show somebody something like that and then they just don't even believe that. I don't know what they're believing. It makes blood boil, but.
Well, I think, you know, you and every other Lyme patient, chronic Lyme patient, knows that we've been told things that just aren't true. And if you go back to the beginning of Lyme, I can list about 15 essential things to know about any new disease, and they got them all wrong. Okay? Now, when we're told that we don't have chronic Lyme disease, a lot of doctors will base that on serology tests, which are not good to begin with. But consider this, if you look at the screen, our serology tests are made for Borrelia burgdorferi, and here it is. This, by the way, is from the brain of a logger from Twig, Minnesota, and he was sick for 30 years. He died at around age 60, and he was treated with antibiotics for almost 10 years. And yet here we're finding live bacteria in his brain. Now, the blood tests should have picked this up, and he did actually have some positive blood tests. But you know what they didn't test for? This over here. He also had Borrelia miyamotoi in the brain. Borrelia miyamotoi likes higher temperatures than Borrelia burgdorferi, and the brain is the highest temperature organ. So it's natural that Borrelia miyamotoi would be attracted to the human brain. And in fact, in many, many of our brain autopsies, we find Borrelia miyamotoi to be more prevalent than Borrelia burgdorferi. Now, what if a patient is sick, and they have all the symptoms of Lyme disease, and they keep getting tested over and over and over again for Borrelia burgdorferi. But what if what they have in their brain is Borrelia miyamotoi? Then all that testing that was done was for nothing. And now we have a new player that is being promoted. It's Borrelia mayoni. And we have found Borrelia mayoni in different parts of patients, including this one. So this friend of mine, actually, Scotty, had in his brain Borrelia miyamotoi, Borrelia burgdorferi, and Borrelia mayoni was actually found in his testicle. And that tells us that Borrelia mayoni probably likes lower temperature regions of the body, but it also tells us that this might be a sexually transmitted disease. He was treated for 7 years for sure with antibiotics, and still we find the bacteria in all parts of his body. Here's the, that's Alzheimer's. This is the testicle. And what these little highlighted little dots are is the DNA of Borrelia, let's see, this is Borrelia mayoni. And so that DNA lights up as little dots. It's not outlining the whole spirochete. But here, this is the testicle. You can see the whole spirochete.
Wow.
Yeah. So is it sexually transmitted? Well, this doesn't prove that it is, but it's certainly capable. Let's see, here we go. This is Borrelia mayoni in the testicle. This is the same logger. And here's a close-up of that.
Wow.
The original question was, is the testing missing these patients, and are the patients being told that they're not sick because their tests aren't positive? And that's just a ridiculous way to do medicine.
Well, it's like the flu vaccine. The flu, there's like how many strains of the flu, and you're getting a vaccine that only covers like 3 of them. This is the same thing. You're being tested for one form of the Borrelia. And
well, often when I talk and there's a group of physicians in the crowd, I ask the question, how many strains of Lyme disease are there of the species that are considered to cause Lyme disease in humans? And they go blank. It's like, well, we know about, Borrelia burgdorferi. But they don't know that there's actually about 12 strains in America and Europe that are in the Lyme disease family. The serology tests that we use work okay for Borrelia burgdorferi. I mean, I would guess that they're about 50% accurate, but they're very poor at picking up these other species. Then you confuse the waters more, murky waters, when you talk about Lyme-like diseases. Borrelia lone starii, that causes starry disease in Missouri and the Southwest, is transmitted by a dog tick. Mm-hmm. It is not picked up by our Lyme disease serology tests. And yet you get all of those symptoms. You can probably see over here to the right, a lot of these bullseye rashes that I have in this show are actually from Borrelia lone starii. Now, you tell me, is this Borrelia burgdorferi or Borrelia lone starii? Well, it's interesting because one of the members of the IDSA went on the road with all of Dr. Ed Masters' slides of rashes and was telling doctors that you can't treat for Lyme disease on the basis of a rash because none of these rashes were from Lyme disease. But what's the treatment for lone starii? It's exactly the same. So what was his point of even doing that talk?
A small controversy, I think, in the Lyme community. Are we seeing rashes in less than 50% or around 25% of those bit?
Oh, it's almost an impossible number to nail down. In children, if they're bit in the scalp, it's under the hair. If there's a rash on the back, a lot of people may never see it. So it's a very difficult thing. But also, I think there's a lower prevalence of getting the rash the second or third time you're bit. And I think we all know that you can have Lyme disease for 2, 3, 4 years before you're diagnosed.
More.
Yeah. So you might go into the doctor after being sick for 4 years, and you say, I got bit here. And he goes, well, there's no rash.
Mm-hmm.
You know, Lyme disease. Well, that's just what I call specious medicine. It's not based on anything scientific, and it's not useful to the patient. That patient is sick. They deserve something better, so that we can get to the root of what they have and to treat them.
And not base it on, because I know it's like, oh, well, you didn't get a rash. You're not. I mean, that was what was said to me. I had my tick. I had a nymph pulled off of me, and I'm originally from Connecticut, even though I got bit in South Carolina where I live. So I mailed the tick to my mother, and
I'm sure she appreciated that.
Because it was, I shouldn't say it now, but yeah, it's free testing in my hometown. You drop a tick off and it's part of the funded program of the state of Connecticut. So I sent it to her, and I still had my doctor down here like, oh, well, you didn't get a rash, so, you're probably not sick. And that's a whole other long story.
Hospitalized in 1990 with, MS. Years ago, I used to actually run, and I ran through the woods all the time. I couldn't understand why people ran on roads. We have beautiful trails around here. And I went to a friend of mine. She was a doctor, and I showed her the attached tick. And she said, I can tell you the exact words, only 6% of the ticks are infected, and they only transmit the disease 3% of the time. So we'll just watch it. If you get a rash, we'll treat you for a couple weeks with doxycycline, and you'll be fine. And that was the state of medicine in 1991. I'm sorry to say things haven't changed all that much.
Wow.